This is a podcast of Scripps Institution of Oceanography at UC San Diego. To learn more about how you can support Scripps, visit us online at scripps.ucsd.edu. To many, they are cute and cuddly, funny and feathery, with a comical waddle and an amusing disposition. To others, including two researchers at Scripps Institution of Oceanography at UC San Diego, emperor penguins are a marvel of the animal kingdom, possessing uncanny resiliency and unmatched physical abilities. In Antarctica, the frozen continent at the bottom of the world, emperor penguins have adapted to thrive in sub-zero temperatures and bone-chilling winds. Jerry Koeman and Paul Panganis, who have been conducting scientific studies in Antarctica for more than 50 years between them, have dedicated a significant portion of their lives to understanding emperor penguins. They have analyzed the emperor's diving capability, which allows it to reach depths of more than 500 meters. They've also studied the amazing duration of its dives, which have been recorded at more than 22 minutes on a single breath. Koeman and Panganis also have studied the ecology and habitats of the animals, tracking penguin colonies to better understand the breeding, feeding, and overall population levels. But now the hardy birds face a new threat. In their most recent observations, Koeman and Panganis have become increasingly aware of how the emperor's environment may be changing at the hands of climate. The devastating 2001 breakaway of an iceberg from an Antarctic ice shelf vividly illustrated the sorts of changes penguins might face in a new, warmer era. But the scientists also worry about the more subtle effects of global warming. We'll hear from both researchers on these topics, beginning with Jerry Koeman and his first introductions to Antarctica and emperor penguins.
I've been going to the Antarctic for 45 years. 1962 was my first year down there. Anybody that's seen March of the Penguins is aware of what drew my interest to emperors after I switched from Weddell seals, and that is that, they're an enchanting bird, and I was completely captivated by them, not just because of the science, but there's a physical challenge to it. You're really walking on untrammeled ground when you go into these areas, and we were the first to be in several of the colonies there. I call them the closest thing to an alien on Earth for a number of reasons. They breed in the winter. There's no other vertebrates on the ice at that time in the Antarctic. Everything else has gone north, with the exception of Weddell seals, but they're under the ice. So first they have this completely uninhabited habitat that they're occupying for their breeding, and then their inaccessibility is just something else, and they're really kind of otherworldly in the sense that they really live in a medium that we don't understand, and they range throughout that medium as far as horizontal ranging, and they go to great depths.
Paul Panganis has been traveling to Antarctica for more than 20 years. In addition to his duties as a scientific researcher, he spends half of his time in operating rooms as a practicing anesthesiologist. His experience in the medical field gives him a special appreciation for the physiology of emperor penguins, and in particular, their incredible diving capabilities.
One of the areas which we have looked at is that in order for these animals to take advantage and completely use this large blood oxygen store, it means that they have to be able to tolerate very low levels of oxygen, very low oxygen pressures. So the ability of these animals to function at very low levels of oxygen is unique, and it is relevant both to their ability to dive and hunt successfully, as well as it's potentially relevant to applications in medicine, at least to understanding the pathology of hypoxemia, because these animals can withstand low oxygen pressures, which our tissues would be damaged at. In general, if you consider the diving physiology of marine mammals and of penguins, I think there's potential application and relevance, to several areas of medicine. Most of it involved with oxygen delivery to tissue. And examples which you can consider are, for example, heart attacks, where again there's no blood flow to muscle in the heart and the heart is damaged. Strokes, where again there's no blood flow to a portion of the brain and the brain is damaged. And even other examples such as preservation of organs for transplantation.
In 2001, a 180-mile-long, 24-mile-wide iceberg detached from Antarctica's Ross Ice Shelf and collided with the continent at Cape Crozier, one of Koeman and Panganis' emperor penguin study sites. Koeman and Panganis studied the devastation and recently published a detailed report of the colony's decimation and other impacts from the iceberg. While climate science is not their area of study, the researchers are acutely aware of the threats that could be looming as the planet heats up. Many questions are emerging surrounding climate change and the adaptability of emperor penguins.
The main issue is if the Antarctic continues to warm, the reduction in sea ice, because emperor penguins are dependent on the sea ice for about 10 months out of the year, 9 of those for breeding, and they breed successfully, and then another month for molting. And so if that ice starts to fail on them, then the penguins may have a major problem, and it could be a major problem for the adults. I could see the potential of large adult mortality occurring because they've selected poor sites for molting. Now, birds may be a lot smarter than what I give them credit for, and they may be able to find other areas. We know that a lot of what they feed on is dependent on sea ice as well. And with the sea ice cover gone, that could change also. These birds may have problems dealing with a changing environment depending on how fast it changes. The emperor penguin is a very vigorous bird, and I think it's probably quite adaptable in obviously the kind of lifestyle it has. It's got to be able to cope with some major changes. But if the changes are too rapid, they may not be able to make those changes, or if they do, it may be at the expense of a major population decline initially, and then maybe recover from that later.
This is Wendy Hunter Barker for Scripps Institution of Oceanography at UC San Diego.